We are now live. Okay, hello everybody. Uh, my name is Łukasz, and we will wait 5 more minutes for the people to join. So be with us for a little while longer. Okay, so we will be starting the event. Once again, welcome everybody to the 19th PyData Trójmiasto event. And to go from the beginning, I will say a couple of words about PyData itself. So the event is something that came up from the NumFocus Foundation. This is the foundation which gathers all of the PyData Trójmiasto, PyData events. There is 208 groups of PyData meetings, events in the world, and we are also one of this. For now, PyData gathers over 196,000 members and located in 71 countries, and the number still increases. And I hope many of you who haven't yet joined PyData Trójmiasto group, for example, will join us. A couple of words about the past events during 2022. So we had two online events and one stationary event. The first event was held in March, and the topics were about the OpenVINO framework, so the framework from Intel, and the data vault concept. The other event held during May was about geodata and an attempt to solve, for example, classification problem using this data. And during the June, we had a stationary event held in Gdański Park Naukowo-Technologiczny, so right here in Gdańsk, about open data concept based on something that's really local, so our data from trams and buses. One announcement about the upcoming hackathon in Gdańsk, so 18th and till 20th October 2022. Our partner AI Games will hold a hackathon for any people who really are like engineers or hobbyists in this area. So we welcome everybody to join. There are still tickets for the hackathon to sign up. So here is a link, and if you're interested, you can join the event. As I remember, last edition was really great, like the best hackathon in Pomerania area. So I really recommend this one. What's more, if any of you like to leave us a message or join for a prelection, prepare a presentation, you can contact us via email or through Facebook page, LinkedIn, and join to our meetup group, which is growing. So please leave us a message also. And about today's meeting, exactly, because the meeting is held during the Programmers Week, we have a possibility to be within this time of from 6th to 14th of September, when CodeMe Foundation is preparing the Programmers Week. And still, there are really cool meetings you can attend. The meetings are in Polish, so this is more for the Polish audience, but just letting you know that there are still some places in a couple of these meetings, and I really recommend joining me and my colleagues during the Hello IT conference, which will be held on 14th of September, so next Wednesday, right here in Gdańsk. And a little introduction about today's prelegents and topics. So firstly, we're welcoming Thomson Reuters Labs, who is preparing team within Gdańsk, and for the first prelection about practical application of language models in the legal domain, based on data from European Court of Human Rights. Dietrich will say a few words about the topic and NLP domain. And Dietrich is Trautmann. Trautmann is applied research scientist at Thomson Reuters Lab in Zug, Switzerland. And the second topic that will be held today is AI economics and delivering production level machine learning components with ModelOps. And here we'll have Martyna Miskowiec, senior software engineer, and Danilo Tommasina, who's leading the software engineering organization in Europe for Thomson Reuters Labs, and was globally managing many distributed teams. So welcome, guys, and thank you for accepting the invitation. Now, Danilo, could you say a few words about Thomson Reuters?
Sure. Hi, everybody. Let me start my screen sharing here. Good. And I'll stay off camera so that you get all the attention on the presentation. Good evening again. My name is Danilo Tommasina, and I'm Director of Engineering, leading the engineering organization within Thomson Reuters Labs for Europe. And I'm also based in Zug, in Switzerland. We're very happy to be offering this presentation to you tonight, and I was really glad to see a good number of people to join in or to sign up at least, even on a Friday evening. So thanks for this. Together with my colleagues Dietrich and Martyna, who will be presenting some interesting AI-related topics. However, before handing over to my colleague Dietrich, let me give you a little bit of background about Thomson Reuters and labs. Here it is. Thomson Reuters is a globally operating company, mostly serving law firm and tax firms, as well as corporate legal and tax. Broadly, we have two types of products: content data access and productivity workflow products. We have lots of editorially enhanced data, which is a goldmine for the development of AI solutions, in particular in the natural language processing space. Let me talk a bit about labs. We are one global team with presence in Minneapolis and Pole area, in Toronto, in London, Zug, Gdańsk, and in Bangalore. We cover the full life cycle of the AI/ML process, starting with customer interactions and co-ideation, over research and experimentation, until maturation and integration into our company's software products. In order to achieve this, we need a variety of skill set with a combination of specialists in design and user experience, as well as in technology, with a strong focus on AI and machine learning. We need as well a generalist that can bundle everything together and collaborate in the integration of the solutions into the end systems. Thomson Reuters sells more than 100 different products. Labs has been contributing AI-based solution in various products. On the right, you see a small sample of AI-powered functionality that has been researched and developed within labs, and that was integrated into our major products like Westlaw, IQ, and Practical Law. In labs, we have a number of ongoing initiatives. Labs performs as an enabling function, serving the entire company and providing various engagements in emerging technology fields. The initiatives include leveraging AI to accelerate and automate tasks that so far could only be performed by humans. In addition, we integrate emerging technologies and methodologies into our product portfolio to solve customer problems in innovative ways. We also run customer engagements with the goal to truly understand and co-create solutions that meet the exact needs of our customers. Finally, we also perform commercial research, whose goal is to adapt generic academic research to the context of Thomson Reuters and find new creative ways to solve unique challenges. For those that do not know, Thomson Reuters has an office in the Alchemia building in Gdańsk. We're current approximately 300 employees. We as labs are setting up a full lab with 16 up to 20 people in the role of engineers, scientists, and project managers. As a member of labs, people contribute into our global project pipeline and work with labs and other TR colleagues, Thomson Reuters colleagues around the globe. And at this point, I'm pleased to hand over to Dietrich for his presentation. I'll be back later with Martyna for our second presentation. Enjoy. Over to you, Dietrich. I'll stop sharing.
Great. Yeah, thanks for the first few words. Let me also find my screen.
It's in front of you.
to share, I mean. So.
Oh, little trouble sharing, so we'll just wait a moment.
All right, seen. So. is it?
Yeah, we can see the screen. It's all full. Yeah.
Yeah. All right, so yeah, hello everyone, and thanks for joining us in this first session on legal prompt engineering. And in this session, I will present you a case study that we did on multilingual legal judgment prediction. And where is it? So here, yeah. So the agenda for this talk is as follows. After the introduction on what prompting is, I will briefly talk about the motivation for this project. I will explain the legal judgment prediction task, the data from academic benchmarks that we used, and the different families of models we investigated. The core of the talk is on the iterative prompt generation, followed by our results on this task. And yeah, finally, I will conclude the talk and we can get to the Q&A session. So first things first, let's start with an example on this whole prompting topic. We see here like a part of the screenshot of OpenAI's playground for GPT-3. This is like OpenAI, this research company, and GPT-3, one of the models that they develop. And this web application allows users to enter text, the so-called prompts, and based on that, they can also change some of the parameters that we see on the right. And yeah, that's kind of the interface. And after they hit this submit button, the model generates then hopefully some useful output. As we can see here, we had the task to reverse a word with some intermediate instructions. And the green part is the completion of the model. And as we can see, the model was quite well in following the instructions that it received for this new word. And then we see also the final result, which is kind of the correct reverse of the word encyclopedia. And this is kind of the basic idea behind this whole prompting. And for the whole field of prompting, I would say this is a new paradigm in natural language processing. Before that, most of the approaches are that we have a collection of data that gets annotated, and then we train some supervised learning models that map from this input space to the output space. And here, this is kind of completely like left out. We just ask the model, the often large language models in a natural language. Those large language models, they are pre-trained on a really big corpora of mostly web text, but some contain also specific legal text or any other domain, medical and so on. And this whole prompt-based learning is based on those large language models that model the probability of the text directly. And prompts can contain questions about the current sample, examples of input-output pairs, or whole task description, as we saw in the example. So the prompt guides the model to generate hopefully useful output. And legal prompt engineering, this is kind of the new part of it. This is applying those prompting approaches to the legal domain where Thomson Reuters is mostly involved in. Another interesting concepts in this regard is also this kind of always thrown around is a few-shot learning and zero-shot learning. And in few-shot learning, this is, again, a distinction between few-shot fine-tuning. This is mostly also from the previous supervised approaches where for a few examples, the model parameters get updated. And the new one in prompting is this in-context learning. And we see an example here on the right. So we have the kind of task description, and then a few of those examples of what we want to do. And then kind of for a new word, the model continues with its own completion. And the other interesting part of this whole prompting with large language models are also in regards of model memory. I really want to mention this, but because the experiments that we have a look later on, they rely on this parametric memory of the model. So all of its reasoning is just based on what it learned during its pre-training. So this is kind of the memory is in the model weights itself, because there are also approaches that rely on non-parametric memory. This is kind of like documents stored outside of the model and some dense retriever or so queries relevant context, and this is kind of used to then provide it for the model to do a completion and so on. The motivation for this whole work is that, especially at Thomson Reuters, we have a lot of data annotation projects, and this is usually done by humans. And even like before human annotators do the task, there is some scouting about possible label sets and so on. And the idea there is to use large language models to assist in this process by suggesting or reducing the amount of possible label sets. The other motivation for this work is, especially for me, really interesting to explore this emerging technology. TR Labs has a strong research track where we can submit several ideas, one of them being this project, for instance, and then we can explore new technologies and kind of test whether we can use some of this information in one of our products. The third motivation for this work is also to look into this new paradigm of AI interaction in natural language. So from the initial example, there was no real coding involved. So this is given the corresponding user interface, non-coding background is necessary, although this is quite helpful. So also subject matter experts with often not a computer science background or so, they can theoretically also be users of this new paradigm. The fourth point being that the whole model training kind of is done beforehand, like on a general web text. And now if we use for one of our particular tasks this model, we do not do any further training. So we can save cost on this model training for our particular task. And the last bit is the model is also capable of doing multiple tasks, so not just one of them. You can do all of them, and we will see here this legal prompt engineering part. All right. So a disclaimer before the whole introduction of the task and so on. This was a purely academic exercise, so there are no current plans to include any of the outcomes in any of our current products. This was really part of the research track to explore this field, because usually kind of the ML predictions are always carefully evaluated by subject matter experts and many other stakeholders before they went into a product. All right. So the task, this legal judgment prediction, the goal there is to predict the outcome, or rather a partial outcome of a court case given a text describing the case's facts. We will consider only this as the input. However, I must say that usually judges consider not only those facts, they take external information about the defendant and the court view and many other things into account until they kind of reach their final outcome that they write. And the data that we used in this experiments, one of them being this from European Court of Human Rights. This is English text data, and it contains those factual paragraphs from case description. So that usually a court case has more than that, and this is really reduced already to just the facts of the case. And this whole, each document is mapped. This was a really intensively manual process to which of those ECHR articles were violated, if there were violations, because some of them there was no violation at all. And the second big dataset that we used was from the Swiss Federal Supreme Court. And here, this is the interesting part, is it contains 3 different languages, so German, French, and Italian. And again, here is also this binarized judgment outcome that we consider as well as in the first one. So we don't map to all of the articles that it violated, just whether there was any violation or not. For the model side, we again considered several types and sizes of those models, and I divided them into those 3 kind of model families, so to say. The first one being the BERT-based models. They are usually pre-trained with a masked language model or a replaced token detection, and we looked there at models like legal BERT or DBERT. Then there is this T5 based models. They are text-to-text models. And we looked there at T5, multilingual T5, and there is also long T5, which can contain has an input really long documents, which of those legal curses are. And the GPT-based models, I will report in this talk only on those. There is basically the task to predict just the next token, and we use this GPT-J6P for the English data, and there is a multilingual GPT-XL model that we used for the German, French, and Italian documents. Another interesting part is by using those models is in the way of how they generate the text themselves. And there are several decoding strategies for this. And we see on the right, for instance, such a tree of like going from token to token. And one like straightforward approach is greedy search. So we just from token to token pick the next token with the highest probability. This, however, results in not like the best output sequence for the full sequence. So there are other approaches developed, and one of them is called beam search. So there we specify how many beams, like full sequences, we want to follow, and then we optimize over the full length of a sequence and pick the one that has the highest overall probability. And there are also other approaches such as sampling, where we have a temperature parameter where we scale the randomness that the model uses for generating the text, or there is also top K sampling or top P sampling, but we don't need to go into more details for them. Another interesting bit for the generation is the repetition penalty. It is especially useful and important for long text generation, because those models suffer that they, based on the input data, they kind of repeat themselves, and we can kind of incorporate repetition penalty there. So that's about decoding strategies. And now to kind of the core of this talk, this whole like prompt engineering. And I will again here describe this for the ECHR task only. We have there, like this is one of the challenges in the legal domain, that there are usually really long documents that we worked with. And although those, as I described, those cases, they were already filtered to just the facts of a case, they were still like really long. And usually like we kind of like work either like on parts of the document, but those GPT models, they were able to process the whole document. So this was great. But if we kind of input the whole document as kind of the prompt to the model, it continues with those facts. So like then we have this completion of the model. And since the input document is like a list of facts, it continues with those facts. That's like not what we want, right? So the idea was then to, this kind of iterative prompt engineering was then to reformulate the task in a natural language. And that's kind of like by writing this question, was there a violation of any human rights articles? And by kind of concatenating the document with this question, we again looked at the completion from the model. And here it kind of sometimes already answered this question, but in most of the cases not, kind of continued either with facts or with other questions on this matter. That's kind of also not what we want, right? So like the next step was then to include those question and answer indicator. So they already helped quite a bit, because they were like, now the model should know, like here we have the question and the answer tag, and so it should probably continue with generating an answer. This was already like really interesting to see, but the one of the final steps was then to include the possible answers that the model should return, because like sometimes it just continued with natural language output, and this is kind of hard then to really map to our binarized outcome prediction. So we have then those A, yes, or B, no indicator. And the final bit of this whole like prompt engineering was to add this end of text token. This was especially like, this is a specialty of GPT models, and by including this, it helped to again generate better output. And now I will show some of the completions that the model generated. So by having this setup like that, we expect it to answer like A or B, right? So like we actually need just one token for the model to generate. So we have like really seen examples with an A generated, and then also with B. However, this was, again, when I mentioned this, and also why I mentioned the decoding strategies, is we have several parameters to optimize for. So one of them being also the length of the generated input. And although we just need one such output token, it was not the best parameter. So I kind of also worked over this hyperparameter, and we settled on 50 tokens for the model to generate. So like, we had then cases where it generated just one, but sometimes it did more. And one such example is here. So we see that it generates A. There has been violations of Article 2, 3, 4, 5, 7, 10, and 11. So like kind of the first token is kind of what we wanted to generate, and then it generated more. And that's like really interesting because the initial task was also to list which articles were violated. And I must say, I looked through some of them, and they like sometimes they align, but they never perfectly aligned. They were like not really all of those articles that were violated, although the answer in the binarized form was correct. So I always, like when I evaluated, I looked at the first token of the completion. And the other set of completions, they continued something like A and an explanation, Article 2, everyone has the right freely to participate in cultural life. And that's like really interesting that it's really like without being explicitly asked, it generates this explanation. So I looked up this particular article, and although an article such as this exists, it was not exact this number. So the model kind of, this is kind of why I mentioned this parametric model, it recalls that it needs to put in a number there, but it is not so sure on the like which number it really is, because like it learned so many other things also, right? So that was like really interesting to see that something like an explanation could be also provided in the answer of those models. And then there are cases where not like an A or B was provided, but there was no violation of human rights articles as the completion. And when I looked through those examples without an A or B as the first token, most of them were in the like no violation category. So I kind of manually mapped them to the answer B. And they were like rather a minority, but not an A or B was as the first token. All right, and then like a funny, interesting completion was like that. So it answers with A, yes, and then it continues with a second question. What is your opinion about this incident? Please explain why you think so, not so. Please write at least one sentence. So that's kind of interesting that, like, again, we haven't asked it to continue with the question set, but probably from its pre-training, it saw some exam style input text, and it kind of now also mimics this exam style by having a second question. And probably if we would allow it to generate even more, it continued with more questions. Having said that, the results that we looked into, this is like, again, here also this zero-shot scenario, because with those long legal documents, we are not able to concatenate a couple of them as examples for the model to learn from. So it's already like this whole document with this task reformulation was already like the full span of the model that it can process. And that's why we stick with zero-shot results, so just the document and the question. And we report the macro F1 on the corresponding def and test set from those two datasets in the 4 languages. And I must say those datasets, they are highly unbalanced. So for instance, for the ECHR dataset in the binarized classification task, 90% were one label. So there was a violation, and like for just less than 10%, there was no violation. So we report additionally also majority scores for this like majority outcome, a random baseline, the supervised scores from literature, and our prompting results for those 2 tasks. And we see them here. And yeah, like looking at the hard numbers, this whole thing is interesting to see that it works. But if we look really at the numbers, they are of course crushed by the supervised models. But I have to say that for the supervised models, the training set contains several thousands of input documents with like the corresponding label, and they trained for several hours. So like, yeah, that's kind of what you get with zero shot. And this was one of the interesting scientific results that we get, that like, yeah, we can work with legal documents in prompting, but of course there is a lot of room for improvement, especially since like the zero shot is quite a challenging setup. All right, so the conclusion for this task is that this like zero shot learning is possible to some degree for the task of legal judgment prediction. There is limited explainability. I mean, like we saw that it sometimes kind of generates those explanations. There are also other approaches that look into the like which part of the document was used, like most helpful for generating the completion, and to kind of investigate whether we can kind of explain the decisions based on that. And like the final point here is that the long legal documents are a challenge in the presented approach, and not possible for the few shot learning, as I said, that like we can't even like we have the full space already filled with one example. We can't have more than that. All right, that would be it. So thanks for listening. Feel free to reach out if you have any further questions. And here we have also the page for Thomson Reuters. And now we can get to the Q&A for this.
All right. Thank you, Dietrich. That was really great presentation and interesting. I was thinking more about if there was anything else that surprised you from the outputs of models.
Yeah, I mean, like I must say that like, it was already interesting to see that it generates those explanations, or like not just the first part that we wanted it to use. It kind of like it really like almost like if you would talk to a human, that like they will also provide maybe like more background of like what they think about this current part, not just like yes, no, that's it.
Okay, something more human-oriented.
Almost, yeah, almost.
Yeah. All right, and another question, because I was thinking how would this model behave when the new data, the law changes, let's say, and there is new data coming, and does it work like if we predict, let's say not predict, but check the legal act that was in the past, if it would work well for the new law, or
well, that's kind of the interesting thing. Like those models, they are pre-trained on general web text, so they could contain some form of like legal documents or like law texts, right? Like at a point in time, but they not necessarily have it, or like maybe it contains also like really old documents or so. So like the whole interpretation is really like difficult in those models. That's why I kind of say there are like sometimes maybe approaches that go into the explainability direction, but it's like really hard because like where does it use this information that it generates its output, right? Kind of like it has this general knowledge, but not necessarily that like one particular law is now changed and so it should judge differently or something like that. That is not part of the process as of right now. And like in this, like if you would run this as a service, you would of course update this whole pre-training and also safeguard the output, whether like this is like also like hate speech or biased output that is not generating. Yeah. Because
those documents, they include dates probably, some timestamps, but I guess the model cannot recognize, maybe recognize it as a token, but probably not understand the chronology or something.
Exactly.
Like
Yeah, I would also interpret like that it's like at which point in time which law applies, and when it changes. Like I think this is currently like not possible with this setup, at least not.
Yeah. All right. Thank you. For me, this is always unbelievable that such a solution can work. Yes,
Yeah.
after seeing the outcome. So thank
I mean,
you.
like as I saw, there is like a lot of room to catch up to the supervised baselines, and this was one of the kind of research like tasks to investigate how far can we get with those zero-shot approaches for the legal domain, because like we saw always this like great progress in other tasks, like sentiment analysis or so. And there we have usually just like one tweet or one sentence, and then we of course can concatenate a couple of them, and then it performs better because like it needs to reason of a really short text span. And here we have like really long documents. So yeah, that's a challenge for humans and for machines.
That's right. Okay, that was a good summary. Thank you, Dietrich, for the presentation. So now, Danilo, Martyna, are you ready for the part?
You're ready? Okay, good. Let me share my screen. Okay. Well, good evening again. I introduced myself before, so together with me, Martyna, she will be presenting the second part of this session. Martyna, you want to briefly introduce yourself?
So hey, I'm Martyna and I'm a senior software engineer in Zug, working with Danilo and Dietrich in the same lab. Thanks.
Good. Second. There we are. We would like to tell you about some interesting topics around AI, and in particular, the development of AI-powered features. I'll be providing some context information about the challenges to be aware of when developing AI-powered features, and how to ensure we can retain a positive return of investment when developing and operating such capabilities. Martyna will then provide more details in the actual process of bringing research work to maturity, starting from the research form being typically Jupyter notebooks, and then mature them with an automation first mindset. But let's start first with some context settings. What use cases do we have within AI development, and how can we obtain a long-term return of investment, positive return of investment, and what do we need to be mindful about? Within AI, there are multiple areas of development and how AI is used. Sorry. Let me do a distinction to begin with. AI-powered features and analytics use cases. These are two worlds with lots of commonalities as well as differences. I'll explain the typical main differences. However, the rest of the presentation will be mainly focused on AI-powered features, since this is the majority of the work that we do within Thomson Reuters Labs. An AI-powered feature, you can imagine it as an extension to an application. It's a functionality, it's a capability within, for example, a web application, or could be even a platform capability. It delivers some value to a user, and behind the scenes, it leverages artificial intelligence to perform the bulk of its work. Typically, we have different owners for the part that is around researching and developing an AI solution, and the people that then integrate it and operate it within a product. Because as of that difference, we typically see usage of different platform and technology stacks even for the development and building of models and the technology stack that is used to integrate and deploy a model within an AI-powered feature is not necessarily the same stack. So, and another difference is also that the roadmap and release cycles of these AI-powered features, they follow the release and roadmap of products. Consequently, also the service level agreements applied to this AI-powered feature are the same of the product these features are part of. If we look at analytics use cases, typically these are this is functionality that is that tries to derive business intelligence out of data to support decisional processes. It can be from somebody on their laptop doing some data analytics and possibly even using AI to run this functionality on a big amount of data and then produce at the end a report, and that report is handed over to senior executives to take some decisions. Analytics use cases can also be more complex. It can be some system as well to produce regularly these reports in a semi-automated or fully automated way. But then you would typically see that the end-to-end ownership of these processes managed within the same team. The development of the solution and the hosting operation of the solution usually happens within the same system and managed by the same team, as I mentioned. The roadmap and release cycle is also managed by the very same team. Service level agreements tend to be also less strict because often it's internal use cases. If somebody is sort of delayed at bringing or producing a report, it will for sure upset some people, but it's not the same as a functionality that is not working within a product and will lead to customers canceling subscriptions. AI-powered features can be found in several variants, from an individual feature to a full capability. Let's use some examples here. Imagine you have a content management system that can do a lot of functionality with documents. And you as a user want to upload your document or your domain-specific text document into this system. Usually the user would enter a summary or a description manually when uploading the document. Now, in order to improve the user experience, you want to add a feature that automatically summarizes the document during the upload process and fills that description in an automated way. This is done via a single AI model, usually, that takes an input, the text of the document, and produces an output, being the summary. This capability is surfaced as a standalone supportive function within a bigger system. If the person that uploads the document changes the auto-generated description, you can gather that as a feedback to understand how well is the model performing or delivering its results. So if the user accepts the text generated as it is, that means the AI did a good job. If the user does some slight modification, not so bad, but you can use these modifications to improve your algorithm over time. If the user discards completely the auto-generated text and changes the entire document or text, and it does this in many occasions, that's a strong signal that the model is performing very bad and action needs to be taken. A full capability would be something like a contract analytics system. The AI-powered functionality that extracts relevant information from a contract is the core functionality of the system. There would be several models that interact with each other and analyze the contracts from different perspectives. In addition, you would offer the possibility to customers to train the AI to work on the specific context of the contracts. Therefore, you would need also the ability to retrain and redeploy models within the running system. and that could be triggered within the application by the users themselves. The feedback gathering would also be very complex and potentially interact directly with the automated retraining system. So full capabilities can be seen as a connection or orchestration of multiple individual features. Therefore, if we ensure that we can deliver a positive return of investment on the individual feature, this will benefit also the work done on full capabilities. I'll focus the rest of the presentation on individual features to keep things a bit simpler. What is that we need to consider when we compute or assess the return of investment of an AI-powered feature? The value delivered by an AI-powered feature needs to be higher than its cost. This is pretty obvious. The key point here is over the entire time of its existence. Now, while this is true for any feature, for AI and ML workloads, this is really a key point, because many people don't realize that maintaining in the long term an AI solution can be significantly more expensive than operating a traditional feature, non-AI based feature. Let's look at a few details. The return of investment calculation should not be restricted to direct monetary aspects. Also here, let's use an example. Self-driving car. What is the impact of a model of AI doing a poor decision? In case of self-driving car, that could be an accident. If that happens, that would be a huge reputational issue for the producer of this AI and for the cars. And that can result in serious loss at the end, because people will not trust you and will not buy your cars. Therefore, what is the impact of the model doing a poor prediction or a bad prediction? This might not be translated directly into money, but can have a strong impact on reputation and at the end on the return of investment. Another important aspect is that that's often forgotten, because people get focused on the research and solving and trying to achieve the best or find the best model to do a task, but typically you work on historical data. Now take also here an example. You train a model, because we are talking about machine learning in this case and not true intelligence. We train a model based on historical data to learn how to extract dates from documents. And typically you would do that on past documents, meaning all your dates might be in the past. Does this mean that your model will be able automatically to recognize dates in the future? You don't know for sure until you test it. And it could be that the model doesn't recognize 2023 as a year, because it never saw that year in his training data. So also here, this is a simple example. There are simple ways also to avoid this problem. But in other examples where, for example, with classifications, you have classifiers that keep changing all the time and being introduced, well, you don't have any training data for that. So it's hard to keep a model doing a good job. Compute costs. Compute costs are also different from traditional features. Typically, you have higher costs doing training. You need to train your models, and you need powerful compute to do that. But also operating an AI-powered feature, running the endpoints which run the AI models behind the scenes, that can be significantly more expensive than traditional features. For example, if you need a cluster of machines with GPUs to run your models, these are very expensive machines. And if you are in the cloud, that might cost you thousands of dollars per day. And if you use such models for, let's say, a marginal feature that is not really deriving or resulting into better customer satisfaction or more sales of your product, well, you might start reconsidering if it's worth running and spending all that money on compute and not really getting anything back. One important aspect also related to over the entire time of its existence is the fact that model quality tends to decline over time due to changes in the data context. Again, an example, if you build a model that extracts information out of product technology descriptions, this is a field which comes up with new gadgets, new hardware all the time, with new jargon, new words that were not known a few years ago. And if you don't manage to update your models regularly, they will not pick it up. And within a few years, or even faster for other type of use cases, your model will start delivering really poor results. Which leads into the next. Long-term costs are massively impacted by the volatility of the environment. Might be the data context, as I mentioned before, but it can be also other aspects like data format. This is a common problem also for data processing pipelines. If you need to retrain your models regularly, you would have to use new refreshed data sets. And if the data sets keep changing their format, you have new fields, new values, you have to change all the data pre-processing pipelines. And that's, again, quite a big cost point. And then we have also the fact that some model architectures are more resilient to change. If we go into the, let's say, using deep learning, you might have more resiliencies than other maybe rule-based engines. But these approaches tend to cost more, both during the training, more compute, but also during the inference phase, also when doing the predictions and running the models in the operational environment. So to summarize, if we have high volatility and high sensitivity in the data, this will lead to higher maintenance cost. If it's not managed properly, you end up quickly that the build cost is, or the maintenance costs, better said, are by a factor higher than the build costs. And this is one of the reasons why many AI projects fail, because people are so focused on the build and don't think about the maintain. And this is why it's important to keep an eye on the return of investment and take measures to do our best to keep the return of investment positive. So first of all, every AI and ML system should define a monitoring and drift detection strategy, and ideally also implement a system that deals with that. There are different ways to implement this, and the complexity and cost needs to be balanced to the risk, sensitivity, and volatility of the environment. The model is of the environment where the model is being used. We could dedicate an entire session to it, and yeah, I don't want to keep you longer than necessary on a Friday evening. A common mistake is also to consider AI and machine learning just as a researcher or scientist think. This is not true. If you want to successfully deliver AI ML solutions with a positive return of investment, you need a collaboration of various skill sets. The artificial intelligence machine learning field is also evolving very quick. And in this technology space, we would love to be able to rely on solid and stable tooling. However, the reality is that there is still a lot of ongoing change and maturation. What we try to do here is to abstract away where we can from the underlying technology and decouple components so that we can gradually upgrade parts of the entire system without endangering its entirety. Automation is also key to keep maintenance costs down and reduce human error. Martyna will cover some of these aspects in her part of the presentation in a moment. Finally, we also want to rely on proven and solid engineering processes. AI and machine learning are nothing else than a specialization branch in technology, and they should leverage also the maturity of software engineering processes. These processes need some adaptation, but the core principles can be applied as well. What does it mean building and integrating an individual AI-powered feature into a product? On the left, we see the model building box. This is depicted as a small element here. In reality, this is quite a complex process with lots of iterations and challenges to solve. It represents the phase where data is acquired, analyzed, prepared, and then the entire research and ML modeling process happens. There are plenty of iterations until a suitable model is trained that meets the requirement and the expectations of the AI-powered feature. Once this stage is reached, the model is published to a model registry as a version of the software artifact. The model registry is a software artifact repository that acts as the interface that allows a separation between the building and the integration phase of the model. This separation enables managing independent release cycles and keep a clear separation of concerns, allowing also for different ownership of what is on the left of the model registry and what is on the right of the model registry. On the right, we have the integration phase. Sorry, PowerPoint acting up here. On the right, we have the integration phase, which takes the approved version of the model and integrates it into an API endpoint. A data pipeline step or something that can be used by the logical layer. So the logical layer interacts with this model and then do a necessary transformation to then interact with the product user interface, which is what is then presented to the user. What you see here on the right is typically integrated into the development lifecycle of a specific feature within a product, and therefore it's also owned by the product team that will host and operate it. It will use the technology stack of the product with some extensions to support AI/ML workloads, but it will then follow the deployment and testing procedures of any other feature within the product. It's also important to note that there are two feedback loops. The one at the bottom on the model metrics takes care of gathering and evaluating input and output of the models, and also gathering corrections or selections done by the user. The gathered information is used to compute how well the model is doing its job. A monitoring system will compute statistical information on batches of input-output user feedback combinations. These statistics, when monitored over time, allow to detect drifts in the expected values and trigger alarms, allowing to take corrective actions. The feedback loop on the business metrics focuses on gathering information like changes in user activity, reduction in time required to perform a task, increases in sales, customer satisfaction. Both feedback loops deliver very important information that drives the decisions around when, how, and which actions need to be taken to counter declines or detect issues in the AI solution, as well as assessing and computing the return of investment. Now, I'd like to hand over to Martyna for the second part of the presentation. Over to you, Martyna.
Thank you very much, Danilo, for your part. Now I'd like to talk to you more what it takes to bring the solution from research to production with ModelOps. I would like to start with briefly describing what are MLOps and ModelOps. MLOps is a way for data scientists and engineers to collaborate and communicate in order to manage the production ML lifecycle. It's a culture and practice in machine learning engineering that tries to bring together the creation and operation of machine learning systems. Some of the MLOps core components or principles are deployment automation, scaling and autoscaling, monitoring, and drift detection. You can think of ModelOps as like a superset of MLOps. So it has all of its features, but it has some additional advantages on top. And it is a system that allows multiple AI solutions and frameworks to come together while retaining scalability and governance. ModelOps is used by businesses to address such issues as data processing automation, training, tuning, and evaluation automation, model release management, or governance. Danilo, you can put the next slide. Thank you. So there are some key differences between work done during research versus the solutions in production. First of all, data scientists, they care the most about having the really high quality of model and to have their solution like state of the art. And they have to really put focus on how well the AI is able to mimic the actions of humans. During production, we like really put more effort on the just on the maintenance and of the high efficiency of the code of our solution. And what we care most during research is fast training, whereas in production we need to have the optimal inference. And during research, we can just analyze the data and we can adapt our model to deal with various cases. But it is not guaranteed that in production there are not any special cases. And we really have to make sure that our system will not, for example, crash if something unknown will reach the entry point. During production, we also have to think about the interpretability, because our customers might ask why AI made this decision and not the other. And we really have to be able to provide the answer. Also during production, it's crucial to have repeatability ensured. We cannot allow a situation where a model with sensitive data show biased results. And for example, fairness might not be the priority during research, but it's important to consider during entire life cycle, because failing to detect the bias might cause serious ethical issues that will impact our reputation and might cause like serious legal actions. And apart from that, as you can see in the slide, like we have to think about our solution to be scalable, to be robust. And as Danilo was saying about it, it needs to be, for example, cost effective. You can go to the next slide. Okay. So research is an experimental process, and since there are different objectives, that translates to coding practices. Researchers mainly work in the Jupyter Notebook environment, and you can see the small example of the notebook environment on the left of the slide. And with working in the Jupyter Notebook environment, they really benefit from the interactivity and visualizations. But it has some crucial drawbacks when it comes to bringing the solution to production. First of all, the dependency management. So while doing your research in the notebook, you basically don't really have a way to specify exact and fixed library version. You have a lot of hard-coded parameters, hard-coded paths, and that really makes the code harder to scale and can make it like harder to understand. Basically, nothing is stopping you from running cells in different order, and that might create mess with logic. It's easy to lose track, also really hard to reproduce. The code is often not modular and it's not tested. And I mean, as an engineer, so we know that it's really a no-go to bring a not tested code into production. Also, when it comes to, for example, version control, like we know how important it is to have a CD, CI, and all the version control things. And basically, the Jupyter Notebook files are just JSON files. So then when we want to merge them, for example, using Git, that is not like a pleasant task to do. Next slide. Thank you. And what we are proposing is basically, for example, doing the dependency management in the dependency management files. The one of our that we chose, like for example, requirements txt or Docker files. We have to remember to parameterize all our parameters, to have our code like unit tested. And basically what we have to do is to keep all of the logic of our code in a separate Python files and leave only basically the orchestration to Jupyter for example, for debugging as well. I mean, Jupyter notebooks are really great for the research process, visualizations and documentation, but they are not really ideal for automation and cleanliness of the code. And this is two really important features that we are looking for having the productional solution. Okay. And what you see here is an example of a simple pipeline that goes from pre-processing the data, cleaning up the data, training, evaluation, checking the evaluation, probably retraining, until we actually register and publish our model in the registry. And like during research, all of these tasks are done in a manual way. So, for example, the scientists can have multiple notebooks open and just click through them, check on and on these results from their cells. And that takes a lot of time and effort. And what we try to do, what we think of doing in production is to bring automation and bring some type of orchestration tool, which will allow us to have this standalone modularized modules and run them with this tool in the ordered way. Sometimes this tool, like often this tool also brings the possibility to have the automated evaluation and have the results written to the registry. And all of this might really bring the cost down. I mean, reduce really human error and assure all of the tasks are repeatable. Because as we know, the main cost factor is human and our salaries. And if we have a model that needs frequent retraining, and can you imagine like sitting in front of a computer for days and days and click through some notebooks on and on? I mean, there are better ways to use our brains and save our time. Thank you very much. And now it's time for Q&A.
Yeah, thanks, Martyna.
Thank you. Thank you, Danilo. Thank you, Martyna. So the first question I've got to Danilo, because you mentioned the return on investment. When you have a system that is already functioning and you're planning to create a new feature for that system, do you look for the return on investment as something just for the singular feature that is calculated, or more from the point of view of this feature and the system working together as end-to-end solution? So the return on investment is about the system or more for the feature itself?
I think the process is similar to any feature that you add to a product, right? Sometimes it's not that easy to say, oh, I added that feature that generated me this amount of money, so you can calculate it so easily. That life is not so easy. But I think the key message is here is often that people don't realize that developing an AI-powered feature is not the same as developing a traditional feature. And you have, first of all, some implications on AI doing something wrong on one side and the reputational impact. And on the other side, you need to factor in higher costs to maintain such a feature. And in the entire mass, right, of all the work that needs to be done, that costs significantly more. Of course, if you have multiple features within a single product, you would adopt similar methodology. So adding a new feature, you rely on what exists already in terms of base infrastructure and processes. So you can speed up many things and optimize. But so you cannot always just look at individual features. But I think really the key point is consider
Oh, just a bit of connection lost. Okay. Danilo,
Like-
I can see your bug.
Yeah, looks like Chrome decided to throw me out. Sorry, it just crashed.
All right. Okay. So, do you have anything to add for the answer, or that was it?
I don't know exactly until when you heard, but yeah, I think the key message is AI pilot feature. It's not just a one-time thing, developing the AI, job done. So there is a lot to follow afterward to keep them up and running and keep producing the results as good as they did at the beginning.
Okay. All right. So, thank you a lot. That was very complex and surprising presentation, because that's probably very true and not acknowledged by many organizations, that the maintenance cost is something to watch out more than just the initial cost of preparing the product itself. So thanks a lot. I've got another question, but to Martyna. Do you have any custom metrics for different parts that you've showed, that there was a interpretability and ethics? So as I understood, you're evaluating ethics part also for during the pipeline in some way, or?
I think Danilo would like to reply to that question.
Okay, all right.
Yeah, and maybe as a Dietrich can chime in if he wants. But yeah, ethics is always it's an important aspect, right? When you are doing the research, the primary goal is to develop a model that delivers to the expectation, but you might not even realize that you are using data that contains some bias. And then you go live in good faith and somebody points out, yeah, but why I'm getting this prediction that doesn't make sense? Just because I come from that country, that doesn't mean I'm a criminal, right? If something like that happens, just because the machine learns what sees in the data it has been fed, that can cause serious issues. So it's hard to say, to quantify and say, yeah, you have to do this, and that, and then you are safe, right? Depending on what type of modeling you are doing, you should be ready for troubles and be prepared and ensure that what you develop is ethically correct. That's one aspect. And then there are other use cases where, you know, certain AI elements are used to, yeah, let's say to find trends that, you know, from the very beginning, they are not very ethical. This is then a matter of individuals or of the company to rethink about what they are doing, if that's really a good use of AI.
Or maybe some kind of discriminating from the model, yeah. Okay, thanks a lot. And I was thinking about the exact technologies. If you could say a word about like platforms that you're using for this.
Yes, we as labs are using AWS as our main platform. We, as a corporation, we cannot use everything as is from AWS. We need some additional tooling. This is sort of homegrown, but the main platform is AWS, so we leverage AWS SageMaker as our core for the development of the models. We have many use cases where we also use AWS SageMaker endpoints for the deployment of the models and hosting them. We try also to be agnostic. And sorry, I went off camera because Chrome starts complaining about my camera, and before it crashes again, I'll stay out. No, what I was saying is we try to be agnostic in terms of the deployment environment. The registry gives us this interface that allows us to take models and deploy them in AWS, in the cloud, let's say in Azure, maybe even GCP, and even on-prem if you want to hurt ourselves.
Okay, all right, thank you. And we have one more question on chat, or even two. You said that the value delivered by AI-powered feature needs to be higher than its cost over its entire lifetime. But what in case when the value becomes lower and the feature is no more precise?
Well, in that case, if that happens, right, that's where you need to take a decision. Okay, what can we do? Can we retrain? Can we maybe upgrade the model architecture to something new and get back to the original value? That might need some additional investment to do that phase. It's sort of a new development, and then you replace the old version with a new one. If you see that there is no way to save it, well, that's where you have to decide to pull the cord. There is no other option, and yeah, replace that feature, abandon that feature. There is no other choice there.
All right, and so is it easier to develop a new feature or adjust the old one if they are somehow compatible, let's say?
Depends on the degree of change. Let's say if you're just upgrading the model, you're just retraining the pipelines work as it is, and it's nicely automated, you just run it and you get it. And that can cover a lot of the use cases. But if you are thinking about upgrading the entire model architecture, you might have to change as your data preprocessing pipeline to adapt to the particular model architecture and the data format required by it. And so it's quite a lot of development. This is sort of a new development. And again, the classic technologist response is, it depends. There is no solution to, or there is no statement to cover all use cases.
Right, that's a fair answer, I would say. Thank you. So I can see no more questions on the chat, and also Victor says that great material, thanks Danilo. So I also add my thanks to his ones, and thank you guys for accepting the invitation and presenting during PyData. So the topics were really interesting and quite complex, I would say. If approaching our own organizations about the ModelOps and the MLOps and return on investment, how would it look like? I'm just thinking about it. So thank you once again for joining. I believe more people will watch the stream afterwards. And yeah.
No, thank you very much for hosting us. It was a pleasure.
Yeah, thanks also from me. It was really interesting to present the work.
Thank you.
And thank you very much from me too.
All right, so thank you, and hopefully see you soon on another meeting sometime, maybe in the future. I hope.
Sure.
Okay, thanks a lot.
Dziękuję. Cześć.
Dziękujemy.
Dziękuję, cześć.
Cześć.